Suppose we have some population and we want to find the population mean. We want to find mu. Now in practice this can be very difficult, right? In order to be able to calculate our population mean mu, we would have to gather data from the entire population. Depending on how big the population is, this could be really expensive. It could be impractical. It might even be impossible depending on the population. This is really hard to find. For a lot of different kinds of populations. By the way, mu isn't the only population parameter this would be difficult for. Any population parameter you want to find would generally be difficult if we have a large population, because we would have to gather data for the entire population. So in this kind of situation where we have some population parameter we're interested in, and it's impractical to find it directly, the next best thing we could do is we can estimate that population parameter. Now the classic way to do this is to gather a sample, a smaller sample from that population, and then use that sample to calculate a point estimate for that population parameter. Now a point estimate is a particular point or value that estimates the population parameter we're interested in. In this case, since we're interested in the population mean mu, the point estimate from a sample that would estimate that population mean would be the sample mean. Okay? We would expect the sample mean to be an estimate of the population mean. And this is much easier to find. We just gather a smaller sample and then calculate the sample mean from that sample. Now this is a great way to estimate the population mean. Generally, our sample mean should be close to our population mean. Depending, if you get a really bad sample just by luck, then your sample mean might be far away from your population mean. But generally, the sample mean should be close to the population mean. But the question then is, how close? How good of an estimate is my sample mean? How good of an estimate is this particular value, is this point estimate to my population parameter? It turns out there is perhaps a better way to find an estimate for a population parameter like my population mean that gives a better idea of how close I might be to that population mean. It's called a confidence interval. Confidence interval. And rather than being just one particular number, one particular value like our sample mean is, it is a range or an interval of values. And we could be very confident, predictably confident, that the population parameter we are looking for, in this case the population mean, is inside that range of values. Okay? The form of a confidence interval generally is a point estimate for what we're estimating for that population parameter minus a margin of error. The margin of error is how far our point estimate might be from our population mean. It's how much of an error there might be, how much of a difference there might be between that point estimate and the population parameter we're looking for. Okay, so this is the lower bound. This is how much we might be, how much that population parameter might be below our point estimate, and then we look above too. If we take that point estimate and add that margin of error, that's how far the population parameter might be above that point estimate. And so we could be confident depending on the margin of error, we could be a certain amount of confident that the population parameter we're looking for is in between these numbers, is in this interval. Okay? In terms of this particular problem we're considering in this section, where we're estimating the population mean, our point estimate is the sample mean x bar. And for the margin of error, I'm just going to notate that using a capital E. So if this were our confidence interval, we would be confident, a certain amount of confident, that the population parameter is in between these two numbers somewhere. Okay? So instead of looking at a single value, it's a range of values. And we'd be confident that our population parameter is within this range. Now, a confidence interval has associated with it a percent level of confidence, which is a probability that that population parameter will fall within our confidence interval. We call this the confidence level. A confidence interval has a confidence level which we abbreviate CL. CL, the confidence level, is the probability that the population parameter lies in the interval. Okay? Generally, we pick the confidence level before we construct the confidence interval because we need to know the confidence level to decide what our margin of error is. Okay? If we want to be more confident, then we would have a larger margin of error. If we only have a small margin of error, we're not going to be very confident. We only are looking in a small region. But the larger that region is, the larger our margin of error is, the more confident we would be that the population parameter is inside that interval. So we use the confidence level to calculate the margin of error. Remember that margin of error is how far the population parameter might be away from our point estimate. Okay, it's the distance. It's how far off our point estimate might be from that population parameter.